Edexcel Core Pure Calculus 5 Integration Techniques. Further integration using arc sin x. So now we are going to extend the use of arc sin x in integration. If we have a close look at this integral, there are a couple of issues here. There is a coefficient of 2 in front of the x squared, which will need to be dealt with, but also it's not quite the a squared minus x squared form that we've seen previously. We have this extra 4x term in the middle of the quadratic. So although we know we can integrate 1 over the square root of a squared minus x squared with respect to x using this standard result, this integral isn't quite in the right form to be used at the moment. So we're going to be using the arc sin x over a to represent our inverse trig function, but don't forget it could also be written as sine minus 1 x over a if preferred. So we need to be able to rewrite this integral in the required form shown here, and hence that should allow us to do the integration. Okay, so if we look at the integral that we are starting off with, which is the integral stated in the problem, and the two problems we have here is the fact that it's not a straightforward a squared minus x squared, and we have a coefficient of x squared which is not 1. So I'm going to do a couple of things. First thing I'm going to do is to take out the 13 from the numerator, just to make it a nice clear 1 in the numerator. And the other thing I'm going to do is to pull out 2 as a common factor in that denominator. So it becomes 7 over 2 plus 2x minus x squared with respect to x. So we've now got 13. I'm going to bring the divide by root 2 outside the integral, and we'll have a good look at what is left. So now we have a coefficient of minus 1 for the x squared term, which is what we would prefer, and I'm also now going to pull a minus out of these two terms, x squared minus 2x in that bracket. So I'm trying to make it look as much like the a squared minus x squared version that we've seen previously. Now if we have a good look at this square root again, 7 over 2 I'm happy with, minus I'm happy with, but that x squared minus 2x, I'm going to complete the square on that to get x minus 1 squared minus 1. And slowly it's getting closer and closer to an appropriate form. 1 over the square root. So I've got 7 over 2 minus 1, which is 9 over 2 minus x minus 1 squared, which is the form required. So we've already made some good headway with this problem, and we've got it into the form from which we should be able to do the integration. So the things to watch out for here is that it's not a straightforward a squared minus x squared, and we don't have a nice simple coefficient of x squared. So by pulling out the 2 from the square root, that allowed me to get the 1x squared term from which I could complete the square and then get it into a much more appropriate form ready for integration. So now we are ready to do the integration. I'm going to do it by a substitution method, but I will show you perhaps a quicker way of doing this as well. I'm going to let u equal x minus 1. du by dx is 1, and du and dx are the same thing or equal to each other. That will be useful to remember later on. So this integral becomes the integral of 1 over the square root. I'm going to rewrite the 9 over 2 as 3 over root 2 squared minus, and it's not x minus 1 squared now, it will be u squared, and the dx is a du. Now we have it in a much more standardized form where a is 3 over root 2. So identifying a is really important when applying the standard result. So now when we apply the standard result, we get 13 over root 2 arc sine u over 3 over root 2 plus c. Don't forget we need to substitute back for x, and I'm going to tidy up this bracket. So I get 13 over root 2 arc sine, and instead of dividing by 3 over root 2, I'm going to multiply by 2 over root 3. And now I'm in a position where I can substitute back for the u. So 13 over root 2, we've tidied it up, and now when I substitute back, we get root 2 over 3 times u, and u, as we saw earlier, was x minus 1. The interesting thing here is if you are comfortable doing integrations by kind of more of an inspection approach, you may have looked at this x minus 1, realise that the derivative of that bracket was just 1, and therefore you may have gone straight to that standard result of arc sine root 2 over 3 x minus 1, because it only needs to be balanced up with a divide by 1 if the derivative is 1. So some people refer to that as a reverse chain rule, which I'm not so keen on, but as long as you realise that you have to balance up this integral, and here would just be balancing it up with a divide by 1. So you could do this with practice by inspection. So the things to look out for here, I would recommend a bit of caution to start off with. Go for the nice simple substitution. Realise that dx and du are the same thing, and that gets it into a far more standardized form. Make sure you identify that a is 3 over root 2 in this case before quoting the result, and then don't forget to substitute back for u is really x minus 1. I would recommend taking out any factors in order to make sure the numerator is 1. That will make the formula easier to use, and perhaps more significantly, try and make sure you have a coefficient of 1x squared. If it's 1x squared, it will be easier to apply the standard result. You need to be able to complete the square very, very carefully in these kinds of problems, and completing the square will allow you to be able to make a suitable substitution and create a standard problem which can be integrated. If you have used a method of substitution, don't forget to substitute back to the original variable. In this case it was x. The steps of making a substitution and substituting back may be omitted once you've practiced this technique many times. Don't try and cut those steps out until you are ready to do so. In the next session we're going to be looking at further integration using arc tan x.